You're given a palindrome string S and a number k and asked to find the kth smallest rearrangement of its letters that still reads as a palindrome when all such rearrangements are listed in alphabetical order. If the string can't be rearranged into that many distinct palindromes, you return an empty string instead. ACO advanced level, rank of permutation problem, palindrome constraint. The symmetry means you only ever construct n2 characters. Mirror gets the rest for free. If that's not already obvious, the rest of this is worth watching. Standard kth permutation, without generating setup, factorial number system over remaining counts. The wrinkle, since S is guaranteed palindromic, at most one character has odd parity and it's pinned to the center. It never enters the half-string combinatorics. Rank space collapses hard. ABBA only yields ABBA, BAB, BAB, both fully determined by their left half. That's the whole reduction. Palindromic rearrangements of S are in bijection with permutations of the half multiset. Counter for multiset frequencies, multinomial coefficients, for counting without enumerating, and digit DP style greedy selection over the factorial number system. If you've done kth permutation before, this is that exact machinery applied to a multiset instead of distinct elements. Brute force is ON and dies immediately, not worth dwelling on. The real move exploits that a palindrome is fully determined by its first CL2 characters, so the search space you're ranking over is multinomial, n2 half counts, not n. Halve every count, isolate the odd one at the fixed center. Note this is alphabet work, not ON beyond the initial count. The half dict is at most 26 entries regardless of string length. Multinomial coefficient computed once as a bound check. Worth noting for interview follow-ups, this blows up fast. For n up to a few thousand, you're relying on Python's begins, and if you needed this in a language with fixed width integers, you'd want log factorials or modular arithmetic depending on what the problem actually wants returned. Classic factorial number system digit selection, just recomputing the multinomial at each position instead of caching it. That inner loop is O alphabet per position, O alphabet per arrangements call, so this whole step is ONS alphabet 22, fine here. But the recompute every step approach is the thing to optimize first if an interviewer pushes on complexity. No validation needed here. The palindrome structure is enforced by construction, not checked after the fact. That's the payoff of doing the work in the reduced half space instead of building the full string and verifying. See Babdik, K2, work it from the half multiset, not the full string. B, CA has exactly two orderings. K2 selects CA, B, deterministically without ever touching the A. The center character is fully decoupled from the ranking logic, worth remembering if a follow-up asks you to generalize to non-palindromic multisets with multiple odd counts. Iter tools, bar permutations, filter, dedupe via set, sort, trivially correct, trivially wrong complexity. Good opener if an interviewer wants to see you establish a baseline before optimizing, bad answer if you stop there. N versus roughly n alphabet 2. Not a close call at n to 10. And the gap is exponential versus polynomial as n grows. If you're asked for a tighter bound, this is ON alphabet, positions times O alphabet, work per arrangements call. So ON alphabet to overall, memoizable down further if the interviewer wants it. 3 things worth flagging in an interview. The upfront total check avoids wasted work on infeasible K. A single letter multiset collapses to exactly one arrangement. A degenerate but correct case. And since S is guaranteed a valid palindrome input, you never have to handle more than one odd count letter. That invariant is doing quiet work throughout the algorithm, and is the first thing that breaks if you relax the valid palindrome precondition. Multinomial ranking over the half multiset, plus a fixed center, same combinatorial pattern as any kth permutation problem, adapted for the mirror constraint. Natural follow-up to think about what changes if S isn't guaranteed to already be a palindrome, or if you need the kth distinct palindrome under a different alphabet size. New drop tomorrow. Quick one for you. If you split the string in half, where does that one odd count letter end up? Pause and take a guess. Think about it for a second. It sits right in the middle. Everything else gets mirrored in pairs, so the one odd letter is the only one that can't be. Second one. We count how many arrangements of that half string exist without ever listing them. Why is listing a bad idea here? Pause and guess. Think about the size of that number. Because the number of arrangements grows factorially, listing them would blow up fast. A formula gets you the count without ever generating them.